Composition of functions, part B. So composition is when you have this open circle right here. This is not multiplication. Composition means open circle. It's saying one function inside of the other's function. So whatever is first function, that'd be on the outside. The second function at what goes inside. So I would always highly suggest to always rewrite this problem so it looks like this. So when we're going through this first one says, I'm going to rewrite it because a lot of times this is more visually appealing to people when you rewrite it like this. We're going to focus on this portion right here first. So we're looking at this. So what this is saying, this equation right here, here's my function of f, and I'm going to plug in -3. This is saying x is -3. Look at my function of f. So -3 minus 5 would give me -8. Now this right here is the same thing as this because those are equal to each other. So this right here will be equal to -8. So I can replace this whole thing with -8. So now I have g at -8. So now this is saying x is -8 because we have this -8 right here in my function of g. Here's my function of g. It's given. So it's x squared. But instead of x, we have -8. So this becomes 64. I have only one answer. This is not a part of my answer. This is a part of my process, not my answer. My only answer is 64. So B, I want you to try to do by yourself, looking at the same way that I just solved it. Evaluate the inside first. So we evaluate the function of g at -3 first. You have to make sure to put that in parentheses. You get +9. So this is equal to 9. So my function of f, evaluate at 9. So I plug 9 into my function of f right here. That's where the 9 came from. So 9 subtract 5 is 4. So my only answer. So what if we don't have a number? So again, first thing I'm going to do is rewrite this like this. So I'm going to rewrite my function of g right here. My function of g that was given is just x squared. The only difference between this, which is x minus 5, and this is it's just changing your variable. So this is just telling you what your input is. So this right here on the inside, I'm going to rewrite as a minus 5. So whenever you have a composition, now I'm putting one inside the other. This is on the inside. So this whole function of a, which is right here, is going to go in place of my function of g. So I'm going to always say a big box, little box. Inside is a big box. Outside is a little box. So this whole thing goes in place of this x. So now this says x squared, but we're putting this in place of my x. So this right here would be my final answer. When I look at this next one, now I can rewrite it as my function of f, g at x minus 2. It's kind of like that same thing. Here's my g of x, this x squared. If I'm going to be plugging this first part in, that would just be what this input in squared. So my function of f is going to be my x minus 5. That's my function of f. That's my outside equation. G at x minus 2 is this right here. So it's x minus 2 squared. This is on the inside. Inside gets full box. Outside goes just around the variable. So this says my box, my x minus 5. So this is my x. This whole thing is my x minus 5. Now you could distribute this by multiplying out my first outside inside last. You don't have to though. This right here is my final answer. I want you to try to do E and F by yourself. So here I first evaluate this inside. So plugging 4 into my function of g, I get 16. So this whole thing is equal to 16. So now let's plug that into function of g again. So 16 squared again is 256. Only answer. When your question starts with a number, you should end with a number. Here my question starts with the x value. My answer should have an x value. So saying the function of f, which is right here, inside the function of f. So instead of writing x, this is my input. This whole thing gets replaced. So it's x minus 5. This goes into your x value. There's nothing to distribute here, so those parentheses could just go away because there's no number out here to distribute because this is still subtracting, not multiplying. Now I can combine my two like terms, so x minus 10. Here the first thing I'm going to do is rewrite this equation. So again, my function of h is this x squared over 2. My function of j is the x plus 1. Inside equation gets the big box. Outside equation is just around my input, so right here. So you know that this gets replaced by this whole thing. So instead of having x, I'm replacing it with this whole thing. So it's x plus 1. This is my x plus 1. You can't combine any like terms there, so that's my final answer. So if I look at B, now I'm starting with a number. I should end with a number. So again, I'm going to rewrite it, evaluate this portion first. So I plug -1 into my function of h. This is where you have to make sure to have parentheses. So this becomes 1/2. So this right here is equal to 1/2. J evaluated at 1/2 is 1/2 plus 1, which is equal to 1.5. You could definitely write that as 1.52. That's okay. I want you to try to do C and D by yourself now. So here is this whole function of j, this whole big box. This goes in place of my function of h. My function of h is where this x is. So instead of having x, I replace it with this whole thing. This is being squared. So x plus 1 is being squared over 2. Final answer can't simplify. Here's a little bit different. First, here's my function of j, or function of h, right here with the x. My function j, instead of just having the x, it's saying have my x plus 1, replace the x with the x minus 4. So this is my x, because that's my input, plus 1. I have to combine these two like terms. That's where the x minus 3 is. So it's saying this right here gets the big box. So this is a big box. My function of h gets the little box. So this box squared. This is my box. Box squared divided by 2. I want you to pause and try to rewrite all of these. Remember, there's 2 ways to write all these problems. And here are the different ways that you can rewrite the problems. So adding, subtracting, dividing, multiplying. Now I would definitely say these are the two that people get confused with. Notice how this is a closed circle, I'm multiplying. Open circle, it's a composition. I would always rewrite this so it looks like this. Again, this is more visually appealing to the eye to know that one equation is inside of the other. And there you have it. You are so much smarter than when you started this. I want you to have a great, grand, wonderful day.